Welcome, everybody. Welcome to my talk about turning GraalVM from research into a product. I'm Thomas. I'm from Switzerland. I was growing up in a small village in Austria, somewhere in the middle of Europe. And when I was studying at university, I was super lucky to be offered an internship at a big American company with a great history. Called Sun Microsystems. Yeah, and at Sun Labs, actually, Sun Microsystems laboratories. This is where, even the Java programming language was started there. And so I was super excited. I was like, yes, this is my chance. Finally, Silicon Valley, America, endless opportunities. So I was working really hard there, and so then later I started to work on compilers and virtual machines. Back then it was a research virtual machine called Maxine VM, and then later I got back to my studies and finished my studies, and I started working at Oracle, which by then has bought Sun Microsystems, but continue working with my colleagues. And I started in a small research setting, but I was really very confident because it was well, just out of graduate school, out of university, I was like, let's go. And so the first thing really for me was, and I think this is still very important when you are starting something. At the beginning, you got to be really bold and foolish. You got to be otherwise your idea or what you would try to do might be too, not kind of, big enough. So at the beginning, we were kind of ignorant about the potential problems we would face, and we were very confident. So we published a research paper, and we called it "One VM to Rule Them All." So. Yeah, as you can see here, me and my colleague Christian Wimmer, we were already working at Oracle Labs, at the research labs. The other people here on the team were still at university because they were kind of students. And we were driven by the vision to create one virtual machine to rule all languages. Because I was working at Sun Microsystems at the Java virtual machine. I was working at Google at the JavaScript V8 engine as well. And I felt like there's all this duplicative work. There's a lot of things that are in common between a JavaScript virtual machine and a Java virtual machine. And why don't we build one virtual machine for all languages? So this is how the project got off the ground. And the initial version was named by us C1X for hotspot. Which, well, if not for a more, a little bit more experienced colleague of ours, Mario Volsko, he told us yeah, this sounds really funny. You shouldn't do that. So that's when we then found out, yeah, a good name would be great as well, and we called it Graal because we were in pursuit for the best answer and the Graal of the. And so that's why then the project Graal really got its name and got started. Now, there was a lot of talks about careers at the first keynote today. I found it very inspirational. And so I thought, I add one slide here, which is my career at Oracle then. And there is one thing I would say about that is to me, the career felt a little bit like being a frog getting boiled. So, you start as an engineer, life is happy, you write your programs, and then you have to lead a team at some point. And you kind of get promoted as a senior engineer, and then you get to manager, you get to director, and so on and so forth, right? And with each step, you feel like things get a little worse. Because, the thing is, as you go upwards, it's you get more and more problems, and you get less and less opportunities and solutions. And people blame you for things, and people are not necessarily giving you compliments or anything like that. And also, when I was a little bit more let's say it was still fun to lead a small team, a team of 5 people, maybe 10 people, so you know everybody, you can work with them, you have still a personal relationship with them, so that's still pretty fun. But then when you go then upwards, to like 30 people, 50 people, 100 people, it's like you really have to work hard not to lose the connection to your people, because it really is a danger that your people become like an entry in an Excel spreadsheet, basically. And so this is something I've been for sure kind of struggling with, to maintain the spirit of our early days when we were small, right? But of course, the reason why I still think it was important for me to go in this direction is that you also don't want, when you want to grow your project and you want to then at some point ship it and have it large scale and in production and on all the platforms and support it and 10 different versions and so on, you need a lot more people than initially. Like the initial research prototype you can build with a few of your colleagues, but as you grow, there needs to be a lot more people involved, right? And you also don't really want to the project is still sort of like, you feel like it's your baby, and you don't want to get it be done by somebody else. So you feel like a certain responsibility that you kind of wanna keep there, right? And you can also ask, why the hell are you 12 years at the same company? Like, what's happening? And I mean, one thing here is, in Europe, this is actually more common. Like Europeans feel like, well, I'm at the company, I'm staying there, I'm feeling some loyalty. Now, another reason, of course, is that I was lucky enough to be allowed at Oracle to build up my own team, so I could hire my people. Like everybody on the team is hired by me. And then it's kind of difficult for me to go to a different job because I have to leave my family, right? So I'm like, so in that sense, yeah, it was very, and this is one of the reasons why I think it's actually not easy if you're in a certain position here to change a company or to go somewhere else, right? Now, one other aspect here, and this is what I'm actually grateful for Oracle to a lot, is that Oracle is a company that thinks here long term. As you can see here, we started the project 12 years ago. And we just, 1 or 2 years ago got our first, paying customers. So we had almost 10 years room where we were working and getting financed from Oracle without an ROI. And if you would have tried that as a startup or some smaller company, it would have been much, much harder to justify this level of investment. And in the virtual machine and compiler space, this level of investment is necessary because of the complexities involved and how long it takes until a technology gets adopted. And I feel with GraalVM as a virtual machine and technology for language execution, we're still at the very early stages of adoption. So it will still take another 5 years, another 10 years for this to become real mainstream. Now, one other lesson I think that we learned, and that was kind of interesting in the project, is that constraints really force creativity and innovation. And I like to tell a story on the project about that. So early in the project, well, we did this Java virtual machine, which makes sense because Sun Microsystems and later Oracle have the Java virtual machine. But I really personally wanted to also go polyglot and compete with JavaScript engines. I wanted to show that you can build one virtual machine with multiple languages. And I also wanted to compete, of course, with my old team, the VA team at Google, so I felt a certain competitiveness, so I can also execute JavaScript on my compiler. And so we tried various approaches and tried to make a JavaScript-specific frontend for our Java compiler. So we tried to translate JavaScript into Java. But we kind of got stuck in the complexities of doing that. And the main problem for us also was we had no budget. Because I was going to my management and said, I want to build this JavaScript thing here. And management said, there is no money in JavaScript engines. Yeah, find something else. And I'll do more of this Java stuff, right? So now we didn't have budget available, but we really, really wanted to do it. So we needed to find a way how to circumvent that. And the good thing is we had these university collaborations, and they were Oracle has a collaboration with a university in Austria, and we had a little bit of extra budget. Not a lot, but enough to fund a master student for half a year, part-time. So we found an unsuspecting part-time master student who was willing to take on the project of executing JavaScript on our virtual machine. And we really didn't have much time or effort to get there, at least to the first prototype, so we could convince management that they should continue maybe with a little bit of more funding. And what we came up with was the primary research contribution we feel that came out of the project. And it was really in this situation where I was like, I really want to do this, but I only have half-time master student, that forced me to come up with a solution that's simpler and better than what's currently there. If I had like the full budget and I could, have a small team, I would have not gone for the best solution. And this solution is what we call in GraalVM partial evaluation of interpreters. So in GraalVM, when we execute other languages like JavaScript or Python or R and Ruby, it's all languages that can execute on us. The way it works is that we build an interpreter for these languages, and then we do partial evaluation of that interpreter into compiled code automatically. And what this does for us is that the compiler is not language specific. So our compiler knows nothing about JavaScript, knows nothing about Python, knows nothing about Ruby. And all the specificity of a language is built into the interpreter for that language. And building an interpreter for a language is relatively simple. Like a master student, a good master student can build a simple, like a subset of JavaScript interpreter in this time frame. And this got us to the point where we could convince management, well, maybe it's a good idea to continue along that path. They, of course, wanted us to put then the JavaScript engine into the Oracle database, which is a challenge, but it led to the next innovation in the project, actually. But we later were publishing a paper about this. This is the practical partial evaluation of high-performance dynamic language runtimes. And as you can see, this is a lot of the names on this paper are the same on the vision paper, except you all see now the Oracle affiliation on them. So by now, most of them have been converted to employees. So yeah, and so then, like when we initially did the project, right, we did a lot of different things, and we envisioned a lot of different things that you could do with our platform. And we really took sort of the approach of like, well, throw stuff against the wall and let's see what sticks. So we tried a lot of different things, and when we went really a big open source launch the first time in 2018, we created a blog post which we called the top 10 things to do with GraalVM. And it listed all the different parts that we think you could theoretically do with our system. And we were lucky that this first initial launch, it kind of got viral on social media. And so we had a lot of eyes looking at these things. And this was super useful for us because now we got some external validation of which of our ideas are maybe interesting for other people and which are just in our head interesting and not really interesting for others. And I'd like to go through some of these now and a little bit on which ones didn't work out first. So we had the idea that people would happily combine JavaScript, Java, Ruby, and R. And unfortunately, that's really interesting from a research perspective. But a lot of people told us, yeah, I don't want to do that. And yeah, there's challenges with it, and we thought, yeah, maybe some legacy code base wants to use 2 languages, etc. But no, this idea was very interesting from a research perspective. We got nice papers out of it, but it didn't like get anywhere. That also meant that tools working across all languages, again, because we felt like, well, we have a compiler for all languages, why shouldn't we also build tools for all languages, right? But the problem is developers in different language communities have very different preferences. And they are not willing to compromise on anything for, that tool being also able to run the other language, right? The other language is probably rather the enemy, and So in that sense, our tools that work across, we had a debugger, for example, that you could use between different languages. You can, even nowadays, you can use the Chrome debugger to not only debug JavaScript, but also our Ruby code, by the way. I mean, it works, but it's still something that didn't got a lot of traction. Running native languages on the JVM was an interesting idea. It was kind of like trying to make C, C++ secure. We tried to interpret C, C++, and or LLVM bitcode in the end, so everything that compiles to LLVM bitcode could be run. And it would actually run more secure, but again, it was a small niche and people didn't much care about it. The other problem we had is a footprint and startup warm-up problem in this project that was just in the end too big. Similarly, extending a native application with GraalVM wasn't really a thing either. People who write native code don't want to combine with anything else. People who write C, C++, they don't want a virtual machine in there. So these were all ideas we put into our blog post that we thought would be interesting, but in the end, didn't make it. Now, we have Java code as a native library. It's something that also people are not using a lot, but it's something we used internally. Because, as I said, in order to justify our project and the budget for our project, we were looking for ideas. How can we make this applicable in a product that Oracle cares about, right? And Oracle cares a lot about Oracle database. So now, the best thing if you're at a large company is to be attached to the best flagship product, right? And so we got attached to the flagship product by saying, okay, we can run our thing in the Oracle database. But in order to run it there, we needed to now link with native code because the Oracle database is written in C. And so this is what got us in the project started with this translation of ahead-of-time compilation from Java to native code. And we use it very extensively in our project. And this is what I will later talk more about this because this is the aspect of the project that in the end got most traction externally. And it's funny here in the sense that for us, this wasn't the primary thing of the project initially. For us, this was a necessary thing we got to do to achieve parts of the project's goal, maybe, but we never thought this would be the thing which other people would, in the end, primarily be using from us. Also, so is creating your own language. You can create your own language on top of our system very easily. And there is some companies doing that, but it's still not like super common. But what was working okay was high performance more than Java. We had a better JIT compiler for Java. We still have a better JIT compiler for Java, so you can run Java applications faster. We got the polyglot story working by this extending a JVM-based application. So in this setup, you have a Java system, you have a Java application, then you want to extend it with JavaScript or with Ruby or with R or with Python. Specifically, JavaScript on top of Java is something people would like to see. And we have a very large also internal Oracle customer. Oracle NetSuite is using this system to execute JavaScript on top of their Java platform. Polyglot in the database also worked out. We got into the Oracle database. We are shipping in production with the Oracle database at this stage. And we are also shipping in production with MySQL since last week. Was announced, actually this week it was announced at Oracle Cloudwell that we are also in the MySQL database. So running languages in a database was something that also was sort of working. But the thing which in the end was the final, most used aspect of the project was the low footprint fast startup Java. So this was the thing where we are executing Java code and we are ahead of time compiling it into a native binary to make it start super fast, make it low footprint, and make it a predictable performance out of it. And for us, we put out this blog post in 2018, and then after 1-2 years, we saw this feedback kind of flowing in. And this was for us then the trigger to make sure that within our project, we have the right investment in the areas where we think, yes, this is something users are actually going to like, and this is something we'll build upon. Now the polyglot part, we really always, we wanted to run all these languages, and we still do, and we still have very large teams writing our JavaScript engine. We have a team writing a Python engine on top of our system. But so we have the challenges that we underestimated initially coming from the Java world is that most programming languages actually lack specification. And this was like something we kind of really underestimated because Java is probably one of the programming languages with the best specification out there. So in Java, every version is very well specified. You have the Java language specification, you have the Java virtual machine specification. And this is super important for the Java ecosystem, because this allowed also for Java to have actually multiple implementations of the language. And what we try to do in some of these language communities is really, try to make sure that there can be multiple implementations of the same language, because it enriches the community, it gives more choice to developers of that language. And in Java, one aspect which is also well specified is the Java native interface. So how does Java interact with C++ code? This is from a document from 1997. Back then it was a company called JavaSoft, a Sun Microsystems business. And Sheng Liang was responsible for writing the release 1.1 of the Java native interface specification. And I'm telling this here because if I look now at a different language, so let's say Python, and you go for Python to the documentation on how do I write a native extension for Python, then it tells you, okay, yes, you can write your native C code, and then what you should do is you should include a header that's called python.h. I mean, that looks okay, it makes sense, right? So, but let's now look into like what is in that header, python.h. And then this is on the right, the font is a little small, but this is an extract from it, from GitHub, from python.h, and it includes everything in that interpreter. Now, if you run that through a C preprocessor to expand the method definitions, it looks a little bit like this. Well, there's PyModule, PyAdd, PyC, ABS, etc., and there's 1,300 more entries to this. Here's your specification. So this is some of the parts we are struggling with most when we implement other languages, and we have the same problem with Ruby. When Ruby, it's essentially the same. So people, and it's kind of, there was the Ruby interpreter, and people started to just write native extensions by including the whole interpreter. And in this way, you have no abstraction between the interpreter and the extensions anymore. And this only not makes it very difficult to create an alternative implementation. It also makes it even difficult to stay compatible as a native extensions between versions of the same implementation. Because now suddenly all of this has become your interface to the world, and if you change it, you will break stuff. And this is why we're very happy, actually. We're quite active in the Python community, and this is why we are active specifically on a project that's called HPy, which is trying to mitigate the situation by creating a better C API for Python. So instead of including python.h, you will include hpy.h, which will be much more narrow in what you can actually access from the interpreter. And this will help compatibility within the Python ecosystem, also for CPython, and it's helping us to implement Python on top of the GraalVM system. Yeah, but this is just one of the aspects I think we underestimated in terms of complexity when we're trying to run other languages. Now, one lesson I think we learned over and we learned it based on user feedback in the end, is that we should really, in nowadays time with the cloud being so prevalent, consider that ahead of time compilation is just better than just-in-time compilation in many aspects. And I'm saying this as somebody who started his career working on a just-in-time compiler and worked on just-in-time compilers for the next 15 years, 20 years. And then, yeah, but when you work very long on something, you also have a benefit that you know all the disadvantages of this thing. so now maybe I will later learn about the disadvantages of ahead-of-time compilation once we do that for another 10 years. But in the end, well, let's say both have a place, but the trade-offs are interesting, and I think it's interesting for a language community. In this case, we're working mostly with the Java community to provide an option for both. And this is what we do nowadays primarily with GraalVM, where you can run Java in just-in-time compile mode, as you usually run your Java program, but you can also run Java in an ahead-of-time compile mode. And this is like looking more like you compile a C++ program, where you take your Java program and then you create a so-called native image. It's how we call these artifacts. And then you can execute them multiple times. And this is what gives Java now a competitive setting in terms of startup time, memory footprint, and so on. That is typically one of the disadvantages of using a heavyweight JVM. And this is interesting because what are the important operational metrics when you execute workloads in the cloud? And you care about the memory usage because it's typically something you pay for. The more memory you use, the larger instance you will have to allocate, and the more money it's going to cost you. You care about the throughput, maybe. You care about tail latency. You care about what is your worst case latency requirements. And then you care about startup warm-up. Sometimes you care more about it when you're doing serverless with Lambda, for example, either with Lambda or Oracle functions. Then you care more about startup warm-up. Maybe sometimes you care less about it. And we have here now an example program that is, we take here the Spring Pet Clinic example, which is Spring is one of the most, it's the most used Java frameworks for writing server-side applications nowadays. And Spring Pet Clinic is their demo application where they are modeling a pet clinic store, right? And we have benchmarked this now, and we benchmarked it on the JIT compiler against the ahead-of-time compilation. And we can see now the first question is, what's the memory footprint of that application? And the answer is, it depends. And my first thing it depends on is how much max heap setting do you give your application? So for all these applications in Java, but also JavaScript, there's now a big debate in JavaScript, I think, between Bun and Node.js, I believe. And then they're saying, you know, how much memory one uses versus the other, etc. Right? So the interesting part is they're like, how much memory something uses depends a lot on how much you configure the garbage collector with. And here I have a graph where I've shown on the x-axis different configurations for the max heap setting. And on the y-axis is the actual memory used by the application. And you can see, like, in this range up to about 1.5 gigabyte, if you give it smaller memory, the JVM will just try to, the virtual machine will just try to not use that. And at some point, it doesn't need more anymore. So even if you provision more memory, it doesn't take more. But another thing to take away here is that the actual memory used is often higher than your max heap size, because when your max heap size configuration is only configuring objects, it doesn't configure metadata. So other things that JVM would use in terms of memory. And now I have the same graph so I'm again checking all the different configurations, and I'm measuring the peak throughput of this application. And this shows you now how memory is traded against throughput typically. So you can, the more memory I give the application, the higher is the throughput. And it's like a little bit of a curve, which shows that there's kind of a sweet spot where, well, at this point, giving more memory to the application doesn't help any much anymore. But this is like, there's a point in the curve which is optimal. And I can visualize that better by multiplying those two things now together to come to a metric which we call operations per gigabyte seconds. So how many operations can your program do when running for 1 second using 1 gigabyte? And we can see here that in this scenario specifically, the head-of-time compilation has a much better trade-off for you. because it uses less memory for almost the same throughput. Or in this case, it's even a slightly higher throughput. So the throughput is kind of the same, but you're saving memory. But this also shows you, and for you as a takeaway, is that when you run these virtual machines, and the same is with JavaScript virtual machine, etc., it depends a lot how you configure the garbage collector. This can depend a lot on your operational efficiency. And in this case, it's 2x. Like if I give it too much memory, I have a 2x worse operational efficiency. If I go now through the operational metric summary, then, well, my memory usage was 40% lower when I use ahead-of-time compilation. My peak throughput is actually 8% higher in this case. Now, some people say, well, this cannot be the case because cheat compilers are so smart and they optimize better than ahead-of-time compilation, right? Now, the truth is a cheat compiler optimizes an application based on how it behaves in the first seconds, maybe first minutes. And then when it's created its machine code, it hardly ever actually re-optimizes. Because re-optimizing costs, again, time, and observing whether you need to re-optimize also costs time. Which means you cannot, in order to later re-optimize, you would have to sacrifice some of your throughput. Some of your time you have to sacrifice, right? This is like it's a very important property that this is just theoretically not possible. And now, what we do in ahead-of-time compilation is that we are creating profile-guided optimizations. So you run your workload on something that you care about, you gather a profile, and then you feed that profile into your run when you create your final binary. And this has, of course, the disadvantage that we cannot react, and maybe your profile is off. But it's also an important advantage, which is predictability. So your profile is not random based on what the app did in the first startup period, right? And it also gives you control over what the app should optimize for. Because otherwise, a cheat compiler will always optimize for the common case. But maybe if something uncommon happens, you don't want to be slow. Typically, actually, in a cloud environment where you want to reduce your tail latency, you want to optimize for uncommon cases because you want to optimize for your worst case, not for your best case. Cheat compiler always optimizes for best case. And with ahead-of-time compilation and PGO, we can optimize for what you think should be optimized for. Now, the throughput per memory, of course, is much higher, as I showed, because now, of course, I get the similar or even higher throughput, but use much less memory. And tail latency is lower because there's less variability in the system. And the startup is, of course, much, much faster. I mean, we don't need to talk about that. Right? I mean, that's the normal thing. But what is kind of new since our last releases is that we have caught up also in peak performance, which means that there is no more operational disadvantage in terms of running it at all. And this is why we think EOT is better than cheat on all operational metrics in this kind of setting. All right, but yeah, so that's enough of the sales pitch. Thank you very much. So, but this has been like the main driver now for our project, this type of increased operational metrics. And this is important also for sustainability because what happens here is that you not only run faster with lower memory, but you also consume less energy. And I'm just coming from Oracle Cloud World where on the keynote on the cloud, they were talking a lot about how they try to reduce energy consumption because it is projected that in about 10, 20 years from now, like a very large portion of energy will go into data centers. And so this operational efficiency is also about reducing energy consumption here. So now my final takeaway and section is that, well, the ecosystem and early adopters are really key to success. And this is so important for the project and has been super important for us. And I'm super grateful for everybody who was trying out our project at the point when it wasn't yet ready. Because you have to have somebody like that. Because you have to get somebody to get that feedback. Otherwise, you're in this loop where like, well, nobody's using my stuff, so I don't get feedback, so I can't make it better. So this is super important, and we try to put a lot of emphasis, and we're very happy that in the Java ecosystem, we have been working with different framework authors, for example. different libraries, etc., that are all working with us to make the system better. Now, our success brings a lot of fans, also some haters, to be fair. Now, when you build something like that, at some point you will always be on somebody's footsteps at some point, and that will kind of. But I don't have anything on the slide because I don't want to give them any space. So, ecosystem adoption has been also good in the enterprise space for us. By now, all major cloud providers have announced support for GraalVM native image. This is AWS, Google Cloud, Microsoft, Oracle, all of them. And we have an open source project. Graal is an open source project. There's also a product associated with it. So it would be something that some people will call it's a corporate open source project. That's true, but it is open source. We have other distributions. Red Hat has a distribution. And it's an open source project with a business model behind it, which means that we have the engineering power to maintain this. And it's a lot of commits go into this thing. We have 4 million lines of code on GitHub for this. So despite the fact, of course, that some people might say, well, that's not a pure open source project, there is a company behind it. Yes, I would say so, but it has also benefits in terms of like there is a sustainable path for this open source project, and it's very, very big, and we maintain a lot of code there. We encourage cooperation with other people, so if you're interested to work with us, or if your library wants to work with us, often we have people working with us with libraries or other projects. We are super happy to do that because we want this thriving ecosystem. And with this, I would like to thank you for your attention. Thank you very much for your time. I will be around at the conference. Happy to share with you. Thank you.